Hello, everyone. Welcome to the first solar viewing from the Fort Worth Society. I am Lunt60. Um, it is a very, very hot afternoon in North Texas. I think we're close to about 100 degrees. That's in the shade. So it's hot. There's not a lot of wind. Luckily, I have water. I have a pool behind me I'm going to jump into once we're done with this. But for today, or at least for the next hour, so we're going to be doing a solar viewing, a little bit about the sun. Yeah, that's about it. So a couple things to talk about. Right now, we're in a solar minimum. What this means is that there are no sunspots whatsoever on. Sunspot is it's an area of the sun in which temperature is lower than the surrounding regions. So while it's very, very hot, it's much cooler than the area around it. So it looks dark. It is not actually cold. It is still very hot. If you took the sunspot and moved it out of the sun, away from it, like let's say you just put in an orbit around it, it would be glowing very, very bright. But it's kind of like when you heat up a piece of metal until it's yellow hot, a piece so hot that it's not melted, but it's just glowing yellow. And then you put a couple drops of water, a little spot, and it turns black. It's not actually black. Take that spot, moved it away, it'd be still pretty bright red, but it's a lot cooler, a lot dimmer than the surrounding area, so it just appears black. Put your finger on it, you burn it off quite quickly. So it's kind of this way we have with sunspots. Unfortunately, we're not going to be seeing any today. I checked the weather on the sun this morning, and the sun's surface is completely clear of sunspots. So instead, what we're going to be doing is using the club's hydrogen alpha telescope. We'll be looking at the surface of the sun. Hope this works out well. And we will be looking for prominences. Don't know if we have anything available right now, but that's why we're doing this. We're going to see what's out there. I had some technical issues today trying to get everything set up, so everything isn't quite set up. That gives me an opportunity that I can show you what's going on and how to do this, how to set this up. Right now, I'm trying to bring up my software. Let's see. I don't remember what my software is called. So let's see, where to go. We're looking at a couple of different things right now. So go ahead and look at the equipment that we'll be using. What I have behind me, it's easy to tell, right over here. This is a new piece of kit that came out from Skywatcher just a couple of months ago to a year ago. It is called the Solar Quest. This is a dedicated solar mount. It does not work for stars or planets. At night, can't even really use it to look at the moon. Dedicated solar instrument. The advantage of it is it makes it really, really easy to use for tracking the sun. What we're going to do is get it set up. Really, really simple operation, actually. So it has one button. Hit the one button, and that makes it work. The volume just here. Hopefully you can hear me a little bit better. There we go. That should be better. So we're going to set the telescope on top of that and see how that goes. I'm going to monitor to see if there's anything, if you have any questions, go ahead and put them in the chat. I'll be monitoring it every once in a while, just to see what's going on. If anyone has any questions, I'll try to answer them to the best of my ability. So next to me, I have the club's hydrogen alpha telescope. So, setting this up. This is a Lunt60. Not sure how easy it is to see. I realize I am in the dark. There's a reason for that. It's hot out there in the sun, and I'm not going to burn myself away for the next hour. So I'm actually here in the shade under my porch. This is the club's Lunt60. this is a dedicated hydrogen alpha telescope. So what this means is this telescope is designed for one thing and one thing only, and that's looking at the sun. It is designed so that you can narrow the bandwidth that passes to just I think it's like 0.7 angstroms. So think of it this way. If you're looking at white light from the sun, you're seeing all the light coming from the sun. It's basically a black body that's shining. But what we want to do is we want to narrow that down, and we want to see just the light that hydrogen gives off when it's excited, and that's the hydrogen alpha light. So we do that with special filters. When we're doing this at nighttime, we use a hydrogen alpha filter to block out all the light except for that little narrow bandwidth, and we can take pictures of nebula with that, and it's a deep, deep red color. With this one, we narrow that down a little bit further. That's why it's a dedicated telescope. We narrow it down as much as we can, and then we're able to tune it. So this little doohickey here, and the way you do it is you pop it off to release the pressure, and then you screw it right back on. All you want to do is release the pressure, and then you put it back on about that much. And what this is doing, this is the ethanol. So it's two pieces of glass, I believe, two pieces of material that are very, 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 very close together. And what you're doing is you're pressure tuning. So you're adding a little bit of pressure or releasing a little bit of pressure to change that angle. And it's this angle that lets you tune in. You're looking at a Doppler shift of the light. So it's the same band that you're looking at, that same narrow wavelength of light, but now you're shifting it over a little bit this way or shifting a little bit over that way. Actually, the shift is much, much smaller than that, but for scale purposes, we're saying it's a bit. That lets you see some of the stuff that's coming toward you or some of the stuff that's going away from you. So if you're looking, let's say, at a prominence on the edge, there's not much that it's going to do. But if you're looking at a prominence on the surface, you can get a little bit more detail out if you can shift that band so that the stuff that's coming toward you becomes more visible. So this telescope is pretty compact, but it is quite heavy for its size. I can't even tell you how many pounds this is. This is probably good 8. Feels like 8 to 10 pounds, somewhere about there. No, it's about 8 pounds. So it feels like about a gallon of water. I have a telescope about this size. It does not weigh nearly as much as this, and that is because of the lenses, because of this pressure tuner, because of the Edelon inside, because of all the filters. It's everything combined together makes this a rather heavy telescope for its size. So what we're going to do, if you notice, this does not have a dew shield because used during the day. Nothing extends out the front like it does with a lot of refractors. Instead, what you have is this filter, and I'm going to try to. There we go. So it's got this blue kind of reflection off of it, or an anti-reflection filter. So Lunt Systems out of Tucson, Arizona. Again, not really sure how well you can see that in the dark, but nonetheless, it's there. Okay, so on the back is another filter. So we have filter in the front, we have the Edelon in here, and then we have this blocking filter in the back. So all the pieces together work to make this thing function. So this is separate, and we can get bigger ones and smaller ones. The smaller ones, which are meant more for visual. This thing's one of the larger ones that's meant for that you can use a digital camera on, and that allows us to do video, allows us to do what we're about to do. So I'm able to extend this out a bit, and then we can move the focus so it goes out. And this gets pretty compact. And once we're done, I want to spread this just a little bit more. Once we're ready for this, then it extends out just a bit longer. So it's small, so it fits into a box, but it extends out as much as it needs to. So the first thing I'm actually going to do is put an eyepiece in here. So I've got a 19mm Panoptic. This actually does come with some eyepieces. I think it did come with some it did come with eyepieces. I do not have them. So here's what it is. I have a 3 to 6 Nagler zoom for visual, and then 16 Nagler for visual. But I'm going to put this 19 Panoptic in here. This will give me a larger field of view so I can center out the sun. Now, back to the mount. The neat thing about this mount is, you know what, I'm just going to bring it over. It's easier to describe this way. Whew, it's hot. So, black equipment and the sun do not make for a good mix. This is the mount here. What we're looking at is a Vixen style dovetail mount on this side. It's my family over there enjoying the pool. I wish I could. Nice and cool in the water. So again, back to Vixen. We have a bubble level on top. There's another bubble level somewhere. Bubble level on the tripod as well. This right here, this is a camera. So when this comes on, this is the camera that is looking for the sun. Now, when you first set up, it takes about 2 minutes. Now, once it kind of knows where it is, it takes about a minute to actually work. So we'll test it out. What you do is you plop this on the ground. It actually has 3-axis sensors in it, so it can figure out if it's close enough to level. You point this to the left of where the sun is. You do not have control over up, down, left, right in any manual way. Everything is electronic. On the back of it, spin this around. On the back of it, you have really simple controls. You have a power button, and then you have an 8-way jog switch. It just moves around in a circle. That's all it does. You turn it on, you give it a minute, 2 minutes, it will find the sun. You have your scope in here, use your visual eyepiece to take a look. You center out the sun. Once you center it, hit the power button once. The indicator light flashes. It tells you everything is good, that it's recentered the sun. Once it's done that, you can start your observing. So what we're going to do is put this right back to where it was and turn it on and hope for the best. So, before I do that, I want to see if anyone has any questions. I don't see anything. Audio is good. Excellent. Okay. So let's get this set up. All right, again, take this and we point it to the left of the sun. There. Oh. We've had clouds on and off this afternoon, so when I was trying to get it set up earlier, I got clouded out. So I had to wait a little bit, and then it was too late. I had to start this. So let's get this thing hooked up. Balance point right about here. So the mount actually does have a, what do you call it? It has a, what was I going to say? Now I forgot totally what I was going to say. Oh, yes I do. The mount itself is battery powered. It runs off of 8 AA's, but it does come with an AC adapter. So if you have a 12 volt, I think like a, I believe it's a 0.5 to 1 amp adapter, it'll plug right into it, tip positive. And now I'm pretty sure trying to figure out where it is. Actually, I'm going to go over there and, oh, there it goes. So it's got GPS. It's figuring out right now where it is, or it just did figure out where it is, and now it's moving to where it should be. Now that's pretty cool. That is actually pretty cool. So this mount will be, once we're all done with this quarantine and social distancing, This will be used for club outreach. Previously, we were using an equatorial mount, and the equatorial is very, very nice for doing night stuff, for doing photography, astrophotography. It is not good for doing stuff visually during the day. For a mount like that, you need to align it to Polaris, to the celestial north pole. You can't really do that. So, not during the day at least, not easily. So instead, we can use something like this. What this does is allow us to easily, quickly target the sun, keep it in the center of view for people to look at through the eyepiece. In case you didn't notice, a cloud has come over. Absolutely perfect timing. So I'm going to see if I can see anything through the eyepiece right now. At least get it a little bit focused, and see what happens. Hang on. No, got nothing. Nothing at all. Yeah, that's where we're at. Been nice, pretty sunny all week. Right now, today, I'm actually hoping that tonight we will have clear skies for our party, but no guarantees. It is partly cloudy right now. You can see me a little bit better. I can see myself a little better on the monitor. But I cannot see the sun through there. With a normal telescope, let's say we had I don't know, let's say we just had a regular refractor or a big Schmidt-Cassegrain, I could actually put a filter on it, a white light filter, which looks basically like a mirror. I would put the white light filter on it, and we could actually pierce the clouds and see a little bit of the sun, at least see the sun's disk. We can't even see that now. The hydrogen alpha, the bandwidth is so narrow, and so little light actually gets through to the eyepiece that clouds like this we just can't pierce. So instead, we have to play the waiting game. I'm going to take a quick look to see. Oh, here we go. Something's coming out. Oh, cool. All right. Well, that wasn't much of a wait. I want to go ahead and start looking. I can't see a thing. Not quite centered where it should be. I don't see it. No. Can't see anything right now, so I don't know if it's moving actually. Try something here. Yeah. So now the trick is, that's not working. How do I get it centered? Little tool here. Does it work? I don't know if this is actually working right now. I'm going to reboot it. It's been working fine, but this is the first time I'm using the AC. How close we can do this. status is not green. Oh boy. Okay. Green light on here that should be shining when it's working. Not. Well, this might be a really short event. On my desk, oh wait, on the side desk by the printer, there's a block with full of batteries. Can you bring that, please? Thank you. Get my wife to get the battery pack and see if that helps. Not getting a green light on status, so I don't think this adapter is going to work. And I'm done. So when my wife comes and gets that, sorry about that, technical issues. This is the actual AC adapter. It's pretty small, and all it is a plug on the back. So it plugs in on the inside, and it's supposed to get power, but I'm not getting it. It turns on. You saw that it did the alignment, but then the status isn't green, and it's just not doing anything. So, waiting for my wife. It is really hot. I've got to get a drink. Excuse me. So if you have any questions, now's the time to ask. I'm waiting. Oh boy, here we go. Yep. So here we go. All right, I don't see any questions, so we'll just go on. Thank you. So battery pack. Just got drag this over. So battery pack has just 8 AA's, and then it's got the plug which matches. So I'm gonna take it, plug it in, we'll try it again. I should have enough power on these batteries. Relatively fresh. Alright, once more. This feeling. Lighting up. Flashing. Gotta get the GPS signal now. Give it a minute. I think it's the AC power. I don't think it's a very good adapter. So that I actually had to strip that off of some network equipment that I had that had the same size plug and had enough voltage on it. Okay. All right, it's moving. Let's see what happens next. But it did move it, so the sun should be centered. It is pretty close. Oh, okay, yeah. Alright, so I'm looking. I see possible stuff all over the edge. Alright, so I'm going to center it. So I'm going to use that 8-way jog switch. One direction. Just centering it out in the field of view. That's centered. All right. Next. I'm gonna get the camera. So, incidentally, I have a 4-year-old who's swimming in the pool right now, so I kind of have to have one eye on him and one eye on this. So he just discovered how to swim without a mask or fins. It was about 2 weeks? 3 weeks ago or so. So it's a little bit more dangerous now. All right, so the camera I've got is a ZWO ASI 178 mono. Again, there we go. That's probably a little better to see. And what this is, it is a monochrome camera. It is 6 megapixel, and the chip size is coincidentally just big enough to fit the entire solar disk in the field of view. So what we're going to do is plug this in, pop it on there, and get into the software, and hopefully everything works right. Let's do that next. Now, that is not parafocal. I have no idea if we're anywhere near focus right now. So what I'm going to do is bring up SharpCap Pro. I'm going to connect to it. Switch. There we go. So bring up SharpCap, and I'm pretty sure this isn't what we want to see. So I'm going to knock this down to 33%. Let's go. What is our exposure? We're doing a 27-second exposure. That's not going to work. We want short exposures. We want very short exposures, actually. Let's bring this way down. There we go. That's much better. Probably get it way lower than that. Oh, man. So quick picks. How about 4,000th of a second? So this is way out of focus right now. I'm going to do a couple things down here. I'm going to make sure that my gain is not way up high somewhere. We don't need to, I'm not going to worry about the histogram right now. We don't need to worry about pre-processing. Just want to know my gain isn't very high. My brightness, I don't need way up there. Don't need binning. Max frame rate is good. I'm not going to worry about the flip right now. And we're going to do mono 16. We want mono 16. Want the maximum resolution we can get with this. Binning is 1. Output. I want output serif file. We want to do fits or TIFFs. I'm going to leave this TIFFs because it's fine. We can do both. Nonetheless, so I've got a blurry sun. That's not going to work. So what I'm going to do is a little bit bigger, and I'm going to try something. Okay, this will be fun. So I'm going to have to go over there, and I'm going to have to play with the focus. And I need y'all to yell when it's in focus. Is that going to work? That's not going to work. I'm going to have to keep coming back and forth. So I've got it so I can kind of see the monitor, and hopefully look at this thing in focus. Recenter it as well, and then we'll see what we can find. Focus, focus. Focus, focus. Touch. See, and usually when we're doing this, we have the monitor up really close. But I'm gonna have to cut this thing way down, even more so than 1/4000th of a second. Let's do this. It's got to get lower than that. Yeah, that should be better. So I'm going to recenter it. Center. Oh, wrong direction. It's always in the wrong direction, isn't it? No matter what you do, it's always in the wrong direction. How focused is that? Can we see some granularity? I think we can see a little bit of granularity. It's kind of hard for me to tell, but it's not bad. At least we got it in here. So I'm going to zoom in, get 100%. I see some granularity in there. That's not too bad. That's not too bad at all. We got granularity. So I don't know if you can tell. I hope you can. But what we're looking at is the surface of the sun in hydrogen alpha light. Right here, I see something. These are some actually really neat features. So there's a little dark spot here. There's a path right over here. There's something closer to the edge. There's some interesting stuff. So this is the surface. I'm pretty sure we can get a little bit better focus on it, but it's kind of hard to do that right now. I want to zoom in really close on the edge, though. So it's not quite in focus there, but it's getting there. I'm gonna be honest, my monitor is dirty. So it's really hard for me to see exactly what's going on because I actually have fingerprints. I think they're 4-year-old fingerprints on here. I've got to clean off my screen just a tad so I can see what's going on. Okay, so we can see some granularity. We can see some movement. I don't see anything on the edge. So when we're looking at the surface, we're looking at these granules. And what granules are, these are convection cells on the surface of the sun. So what we're seeing is upwellings of basically plasma coming from deeper down in the sun, hitting the surface and boiling over. There's, in terms of what's going on, it's not very much different than if you're boiling a pot of water and you have a hot spot at the bottom of the plate and it keeps setting bubbles up from the same spot. So the water rushes up, hits the surface, kind of boils over a little bit, and then comes back down. And you have these cells, and they're doing the same thing where the hot material goes up to the surface, spreads out, and then cooler material comes down to get recycled. So you have these all over the sun, and we just call them granules. So if I zoom back out about 100%, we can go down. It's kind of hard to see, but these granules actually do move over time. What you're seeing right now, this kind of shakiness, one, got a little bit of wind. Two, it's the atmosphere. It is hot. So, and it's heating up the telescope, it's heating up the equipment. It is going to move. That's just what happens with solar observing. There are a few ways you can get around it, but not very many, and pretty much it involves expensive cooling, and we don't have any of that. So right now, I'm going to see if we can see anything on the edge. I'm not going to worry about the South Pole right now. I suppose we should center it out. You know what? Let's go ahead and do that. I'm going to switch back to 50% and scroll down. I want to be able to get the sun a little bit higher so we can see the bottom. Right direction. Always, always, always the opposite. There we go. No matter what, it is always going to be the opposite direction of whatever you first hit. Okay, we got something over here, maybe? Or is that just my monitor? I think it's just my monitor. My screen. All right, here's what I'm going to do. Let's see if I have any questions. Anything at all? No. Okay. All right, so here's what we got. We have to worry about two different exposure levels. The stuff that we're seeing on the surface is very, very, very bright because it's very, very hot. There's a lot of light coming from it. The stuff we want to see on the edge, the prominences, that's not very light at all. In fact, it's significantly cooler than the surface, so it's going to be much dimmer. Because it's much dimmer, we need a much longer exposure in order to see it. So we cannot see both the surface and prominences at the same time. We have to pick one or the other. Now, if you're doing photography, we can actually take video of everything. We can take video of the surface of the sun during this really fast exposure, so we can get the granularity, we can see the surface, we can see all those interesting details on the surface, and then do another set of exposures to look at the prominences. So I'm going to push up the exposure because what I want to see is this. I want a bright, bright, bright sun, the solar disk, I should a really bright solar disk, and I want to see along the edge we can find anything interesting. All right. I don't see anything here, and there may not be anything interesting right now. Usually there's at least something. I don't see anything yet. And it is kind of hard to see outside on a monitor, but just looking at the edge, there's nothing which is really popping out saying, hey, I'm a prominence. I'm going to bump it up just a little bit more, maybe do something slightly dim. Oh, here we go. Now we got something. Now we've got something. Here we go, right there. We got something on the edge. That little bit right there. And it's... how about disable that? And... we did see something. I don't see much of it here. There's a little bit coming off right there. So this whole edge of the sun. Let's go up and see if there's anything that we missed on this side. Don't see anything. Usually when you expose it this much, if there's anything large, it'll pop out pretty well. Could it be the focus? Could it be a lack of focus? Entirely possible. And while I do have a motor focuser now, I don't have it on here, so I can't do it remotely, which is really too bad because it'd be perfect right now. And this uses, yeah, mine won't fit on that one either, which, oh well. So I'm going to go over there and I'm going to watch this. Here's what I'm going to do. I've got a large exposure. I'm going to get this right on the edge. And I want to see if I can't get that edge a lot sharper. So now I can actually see it from way out over here. Trying to focus. Sharper. Hard to tell. I don't think that's sharper. I think that's actually a little bit, I think we need to go the opposite direction. Almost had it. Close. Is that closer? Is that further? That's hard to tell. All right, I'm going to zoom back out. There's something possibly over here. Don't really see anything. I don't really see anything. We might not actually have anything to look at. No prominences off the surface. Let's even go down and see the other one. Where that one was before. Don't see anything. Maybe it's too much. Cut down the exposure some. Yeah, I don't think I'm quite in focus. I think that's what it is. So let's bump this up a little bit more. I think I should have some auto. Oh, here we go. Auto gain. We turn off the gain. Auto. Yeah, we do not want gain turned on. Frame rate is maximum. It's fine. I don't see anything else that we can do. Brightness. What does my auto do? Yeah. I don't think we need that. Oops. Way back up. So when I did it that high, something popped up. There we go. So we do have something off the edge. There we go. There's something right here. There's something right here. Oh, we just needed to bump it up even more. That's what it was. Okay. So we have some prominences that are coming off. It's not a whole lot, but we do have two right there. So we did see one earlier. That was this one. So just looking at the edge, we have something coming off. Let's look up more. Moses, come here. First time on camera. So what we're looking at here, these are prominences that are coming off of the sun. They're big pieces of gas of plasma that the sun is shooting off.
I see.
Thank you. Oh yeah. Call home. Bye. You gonna jump in? You gonna jump in? Yeah, he jumped in. Okay. So, see those two. Let's go up to the north. There's something coming off right here. So we have there are a couple of different types of ejections that we have off of the sun. So we have a prominence. What prominence is, typically associated with sunspots, you always have a positive and a negative sunspot. They're always in pairs. And what happens is the magnetic field inside the sun is twisted around and around and around because of differential rotation. The poles of the sun, the north and south poles, rotate slower than the equatorial region. And so these magnetic field lines inside are trapped, and they're rotated around and around and around and around until basically they just snap and they pop through the surface. And where they pop, the sunspots form. And the reason why they form is something called magnetic cooling. And this is actually a technique that we use to create very, very cold gases on the Earth. And so temperature is really a function of the movement of molecules and atoms. If you can stop the movement of a molecule or an atom, its temperature drops. So the trick with magnetic cooling is you have let's call it a hydrogen atom. You have a single hydrogen atom and it's moving around in all directions. If you add energy to it, form of heat, it's going to be moving a lot more in the same amount of time, and we call that temperature. Well, if you confine it in a magnetic field, now let's say you have straight vertical magnetic field lines. Now it cannot move in this direction. It can only move in this direction. You've constricted its movement, so its temperature is now dropped. In the magnetic fields on the sun, you have the exact same thing going on, where these massive magnetic fields are constricting the movement of hydrogen gas, in this case of plasma, which is charged, and it's not allowing it to move so much left-right, but only up and down. And when it does that, the temperature drops, and in that region you have a sunspot. It is now cooler than the region around it. Well, these magnetic fields make big loops, so you have the surface of the sun and a loop of magnetic field, basically field lines, which comes out. The gas will follow those field lines. When it does, it makes this big arch coming off the surface, and we call that a prominence. When the magnetic field line expands out, this prominence follows the lines, and it can blow out too. So you can have a large prominence, which is a tenth the size of the sun, blowing off and expanding and throwing that material off into space. It is much, much, much bigger than the Earth. Most prominences, you can easily fit the Earth underneath the arch. So that's one type of ejection. We also have a flare, and a flare is similar to a prominence, except instead of looping back to the sun, it just blows straight out. So a flare is a small one, and then we have what's called a coronal mass ejection, which you can just think of it like a super flare. It is a large outburst of gas and materials. And the problem with coronal mass ejections is that if it's aimed at us on the Earth, it will, in a matter of hours, hit our upper atmosphere. And when it does, sorry, let me rephrase that. It will hit our magnetosphere. When it does, it causes the entire magnetosphere to ring back and forth. It also sends charged particles down towards the north and south magnetic poles, where it causes really, really bright aurora. The issue is that this ringing of the magnetosphere causes magnetic field lines across the surface of the Earth to move as well, and all the charged particles don't help either. So we do actually have reports from the 1800s of what we now think is a coronal mass ejection. And what happened was it caused fires in telegraph lines, as in telegraph lines actually collapsed in flames, and there were a number of fires associated with this, and lines were down all over the United States because while the movement was very, very small on a small scale, what you ended up happening was these lines were thousands, 1,000 miles, 500 miles long, up to 2,000 miles if it was going to cross the entire United States. So you have 2,000 miles of cable, you have a moving magnetic field, you're actually generating a lot of current doing that. So that is a big risk that we have now. If we get hit by a coronal mass ejection, then that can cause very large currents in lines that aren't necessarily meant to carry very large currents. We have not had that happen yet, at least not in the technological age that we're living in now. As I don't believe we've ever had that. We've had outages due to coronal mass ejections, but not on the scale that we had in the 1800s. So, all right, so this is moving a little bit further over. So again, it's not tracking perfectly. For visual purposes, this is fine. Let's look at the north, see if we can find anything. Again, we're just overblown. Yeah, it's tracking a little bit up high. That's because I didn't recenter it. That would do it. On this side, seeing anything? Not really much. There's stuff. There's something over here. Something possible over here. But I don't really see anything really special right now. This is all I got right there. And I'm going to see if I can't make this a little bit more so you can get more detail out of it. Oh, almost had it, didn't we? Oh, there we go. So, hard to get right, isn't it? Too much or too little? We can see these ejections here, and we can see that one right there. So these are probably flares, probably not prominences because I don't see any loop type structure. This is extended. This could be a loop, but it's just really hard to tell. The way I would do it is I would just start recording frames, just start recording a lot of frames, and then drop this down so that the surface wasn't blown out completely. Oh, we also have a cloud going. We have clouds going over, so it's getting a little bit dimmer. Not too bad. Let's see what that looks like. Just out of curiosity. At 40%. Yeah. So this is what we got. We got clouds moving over the surface of the sun. But if I drop this way down, we can see the granularity. And if I was going to be doing video, I'd pop this up so that the surface was not quite white, but getting up there. Probably a little bit more than that. 12, a little bit more than that. Let's go. I think 20 was too much, so somewhere in here. I'd be videoing it about like this, because what I want the inside not to be pure white, and then I don't want the outside to be necessarily black. Out here, yeah, that can be black, I guess. But what I want is a maximum range of values for grayscale. And this is actually a grayscale image. This is a monochrome camera. If I put in the color camera, all you see is red. And it's really difficult for our eye to differentiate shades of red. So instead we do something like this. We use a monochrome camera because we're only dealing with one wavelength of light anyway, and it's red. We don't really care. All we care about is the image quality. So we'll get that, and we'll keep doing it. Okay, so it says adjust the tuner. Yeah, we can try that. So I'm going to blow this up again. Where were we? We're up there. So I'm going to knock this back down to 300. That we're worth 300 or so, somewhere. So we've got those there. I'm going to go mess with the tuner. Let's see if we can make those pop a little bit more. I don't know if that did anything. Someone's having fun. How's that? I don't really see much of a difference. So, yeah. I think what I would probably have to do is spend a couple of hours here really doing is a lot of video. Ah, it's way overblown right there. Yeah, we do have something here. So I have seen before curtains, and if I drop this way down again, I get to at 200. So what a curtain is, <sighs> way too little. So on some of these, if features and just tune it just right for the exposure. That's too much again. 12.5, okay. So in some of these features, what you'll be able to see is a dark band coming across. I think we had one here and it looks like it's disappeared now. It's not the way it used to be. What that does is you can think of it like a fissure on the sun, and these fountains, a curtain of material is coming up. And if you record this over a period of hours, you can actually see a lot of changes. Sometimes it'll start off a little bit slow and then it'll explosively burst out. And we say explosive because it does take several minutes to hours for that to happen. Remember, the sun is big. The sun is quite big. So if I remember right, it's like 1 million Earths will fit inside of it. Like 300,000 miles across. Something like that. I can't remember the exact size off the top of my head. Let's find out. That's what we have the internet for. It is 432,690 miles across. So it is quite large. The Earth in comparison is just under 4,000 miles wide. So quite a bit larger. And because of that and speed of light limitations, stuff that happens on the surface of the sun takes a while to evolve. It's not right away. But it is kind of neat. So I'm gonna play with the focus a little bit more. I'm gonna see if I can get it a little bit closer to true. I want to get a little bit better granularity, and I want to see those prominences that are on the edge. So yeah, it's just one of those things where it's just really, really hard to do. Running over there, then running back. Running over there, then running back. It's not quite in focus. Better? Is that worse? That's just so hard to tell, isn't it? I guess that's probably not the best way of doing it, zooming in that close. How's that granularity? You think that's better? I think it's a little bit better. Let's boost it up and see what we can find here again. So that was about 200, 400, 210. There we go, 210. That's actually, that's slightly better. So looking at this one, I think this has actually evolved since we first started looking at it. It's gotten bigger. Let me get a little bit closer to it. Got lots of pixelation, but you can definitely see there's something there. And it is actually blowing off some material off the surface of the sun. And the one next to it, down here, this looks like it's actually much larger. So what this could be is something either here in this region blowing up and off, or it's just on the other side of the sun and we're seeing it come over the edge. It's just really hard to see right now unless I do a lot of video, take a lot of frames, and then start processing them. It's not that easy to do live solar processing, especially when it is so hot. It's just stifling, and I haven't had much to drink and been talking for almost an hour. Oh. All right. That's just water with lemon juice. Just tastes better and lets me keep on working. Back to 200. Take a quick look around again. If there's anything else that's interesting. I do not see anything else on here. There's all sorts of stuff streaming off of here, though. If I move it, yeah, there's definitely, it looks like there's definitely edge stuff going on here. Maybe over here as well, up towards the north. And we're going off a bit. I don't see anything on this side that's obvious. Not like these down here. These two are just really obvious. They're just right there. When we blow up the other ones off the rest of the sun, it is not that obvious. So it could be those are the only two places of activity. Looking up north, looks like there's some stuff going on, but again, it's really hard to see. We had a coronal mass ejection yesterday. Yeah, I believe it was yesterday. I saw something on spaceweather.com. So that's a neat website to check out. All right. SDO showing prominences, but don't know how to line it with what you're doing. Okay. So, what equipment is being used? Jim is asking. So, this is a Lunt60 hydrogen alpha telescope. I have a ASI, ZWO ASI 178 monochrome camera on it. It's not cooled, and the mount is a Skywatcher Solar Quest. So that's what we're working with right now. I guess we can try. Let's use John's suggestion and knock down the exposure a little bit more and see if we can get a focus. It's just so hard to see that edge. With the movement of the sun, it's gonna be really hard to get that. Oh wait, hold on. That dialed in? How's that? That's better? That may be better. All right. Zoom back out to 100. You can see that granularity. Let's go look at these prominences again over here. You have to boost this up to what? That high? Higher than that. Yeah. Oh, I can see its shape has evolved. The one that we're looking at, 200. Yeah, the shape is evolving. Actually, I think this is better. Yeah, I think the focus is better on this one. So I'm going to zoom in even more, and I'm going to see if we can mess with that edge a lot. Oh, wow. We can actually see some shape. So this was a much smaller one, and this looks like it's actually extending out quite a bit now. So this one is growing. That's pretty neat. All right, I'm going to see if we can mess with the... there we go. Okay. I'm going to see if I can mess with the pressure tuner, so we can get a little bit more detail on it. I don't think that did it. I want to push it back the other direction. Say this. It is hot. So, all right, so we can see that. Moving a decent clip too. Yeah, it's not tracking perfectly, but it's not doing bad at all. So we're getting some detail. I'm gonna keep messing with the exposure. I want to get that exposure down a little bit. That's too little. So we can't really see anything. We have the exposure. Double it. It's a little bit more. I'm going to get a little bit higher than that. Get some more detail. That's too much. So I think right about 200. 200 was our sweet spot. So it looks like there's a lobe which has come detached from the sun right there. Oh, what was that? What was that shooting in front of it? I'm guessing that was... I have no idea what that was. Could have been a bug. Could have been a satellite. I doubt that was a satellite. Unless something was reflecting off of it. I don't know. I'll look at the video later. It's not that important. So we can see that one there. We can see that one there. Let's look over on the other side. That looks quiet. That looks quiet. And we've moved off a bit. Got something right there. A little bit of something. Not much. Let's zoom in to see what we can find. At least it looks like it's something. It looks like it's something. It's definitely coming off of the edge, but it's just, yeah, it's just hard to tell right now. There's something there. It's just not enough to see. So here's what I'm gonna do. This one's evolving quite nicely. All right, here's what I'm gonna do. I'm gonna start the capture. What am I doing? What do I want? I want target name. Let's just call it the sun. Ah, the laptop is in the shade and the laptop is hot. All right. So anything? Nah, I'm not gonna do anything special to it. I'm not gonna do a live stack. That's just always a pain with solar stuff. So I'm gonna leave it at 193. And I'm gonna do a start capture. Unlimited. Yeah, let's do that. So I'm recording a bunch of frames. How many frames we got? 23, 24, 25. So just under 3 frames a second. That's not too bad. What I want to do is I want to capture a bunch of frames. I can stack the frames and I can then play with this to see what kind of image I can pull off of it. Now, if I recorded for an hour or 2 hours or 3 hours during the course of the day, I could you could do stuff like stack all the frames in 1 minute and stack all the frames another minute, and then you create basically a minute by minute time lapse of everything. So that's doable, but it's hot. I don't feel like doing that. What I feel right now is just jumping into the pool. So that's actually pretty cool. I like that. If you have any other questions, go ahead and ask them. If not, then we can go ahead and be done. I'll probably leave this recording for a little bit longer and see if I can get some data off of it. So I think I have enough frames right now that I can look at this and say 190 frames. Yeah, we can let that go. I can probably do 300, 400 frames for this. What I want to do is I want this level of exposure so I can look for these prominences, and I can stack the prominences, maybe pull out some more details. But then I want to drop the exposure down a lot more so I can see the granularity. Once I see the granularity, then I can start recording again. When I start recording that, I can stack full solar image, the full disk images, and maybe pull out more information out of that. With that, I can do things like I can perform different exposures on the disk than on the limb. So now I can have an image of the disk with the granularity, and then I can have a second image overlaid on top of prominences on the edge. Now remember, all this is going to be black and white, but you can do false color. You can make it all yellow or red, however you want to do it in post-processing. But for now, everything is black and white. So how many frames I got? 260, that's good. I'm going to stop the capture. Okay, buffered frames, 80 frames, that's fine. So that's pretty cool. I want to knock this down to, what do we have before, 50? 49, probably less than that. Oh, that's too little. I want, let's see, let's go 100%. No, not 100. Won't let me do it yet, so it's got to finish doing its thing. That's kind of neat. It still has a couple more frames to go, not too many. That's nice. Let it keep recording. Yeah, they're having fun. Okay. So I don't see anything obvious. I don't see anything obvious right here that would be causing it, or anything over here that would be causing it, unless this rift is throwing something really big. I just can't see anything right now. We just have to do a lot more image analysis to do that. And you can see this is swimming. This is just, there's a whole lot of movement with this, so I'm not, I don't know how good of an image it's going to be. All right, it's 4:07. And I said I would do this for an hour, but we've gone over. It's fine. It's like every other star party, isn't it? I say 3 hours for the star party, do it for 5. Then one day I go to sleep. Okay, is it done? It's done. I want to go back out. I want to see this whole disc again, 75. And I'm going to go and center it. So I want to see. So you can see we're missing the top. I still want to get that. Let's try again. Always in the opposite direction. Always in the opposite direction. So I want to make sure that I can see this granularity. Okay, I definitely want to make sure I see it. I don't want it to be overblown. So I'm gonna try a little bit higher. 1.5. Okay, a little bit brighter. We have some region over here. That's fine. I'm gonna start capturing again. And unlimited, I don't care. I don't want to limit myself. So what are we doing now? 2.7 again? Yeah. So actually, you know what? I want to stop this capture. I want to call it... all right. What I want to do is give it a different name for the file name so I know which set goes with which. Instead of trying to remember times. So 5 more frames. And I'm actually writing this. The reason why it's so slow is I'm actually writing this. Let me do this. I'm writing this to a spinning disk drive instead of a solid state. I'm doing this for my laptop. I'm not doing it for my dedicated streaming box, which I will have set up when I will have that set up for tonight. So in this case, I'm just doing everything off the laptop. So I do have an SSD for the OS, so everything runs fast for that. But when it comes to actually storing the files, you don't need an SSD. So everything goes to spinning platter, and then from there I can pull it off and put it onto my my network NAS, and I can work from my workstation in my air-conditioned office, and not outside in the heat. Again, if you have any other questions, now's the time to ask. Let this thing keep going for a little bit longer, and I'll gather some data and I'll play with it, see what we can come up with. And if there's anything decent, I'll put it up on the Facebook page. If not, then delete the files. So there's no point in keeping old data which isn't any good, which doesn't do anything, which doesn't help. So tonight, I don't recommend you sticking around. I recommend you doing something else for the next 5 hours. But tonight I will be setting up at least one telescope, probably 2. So I have the club's Celestron 11-inch Schmidt-Cassegrain. It is a CPC 1100 on a Altaz mount. And I don't know, can you see? Yeah, back there I have, actually have 2 tripods back there for 2 different mounts. I will have the 11-inch on there, and I am still deciding what other scope I'm going to be putting on the other one. I have a toss-up. I can either put in the TeleVue 101, which I probably will end up doing. It is a 101 millimeter apochromatic refractor. It is a f5.4, so it is a wide field instrument. The other thing that I could do is I actually have a Meade AR5 5-inch achromat, but I think it's an f9. It's either an f9 or an f7, so it's a much longer focal length, and it's more of a planet killer. So the long focal length lets you get a lot more magnification, which is good for stuff like planets. It is a very long focal length instrument. And because it doesn't have a center obstruction, you can get really nice sharp images off of it. So tonight we'll be looking at the moon primarily, Jupiter and Saturn. We'll probably pick up Neptune, and then probably go for ring nebula, maybe the dumbbell, looking for just whatever we can find tonight. So 9 o'clock is when I should be starting. The sun goes down 8:20, 8:30 or so. but I do need some time so I can do a polar alignment, get some stuff set up, and then we'll just start promptly at 9, go on until I'm too exhausted to go on, and people want to go back to bed, which I would want to do as well. But this is going to be the first star party we've had for quite a bit. We did have one scheduled for last month, and we got interrupted by a hurricane. So the hurricane threw clouds at us during the day. Everything was good until right before, and then it really started to cloud up. I had a little bit of rain right after I packed everything up, and then I think it was just after midnight, everything cleared up perfectly. It was absolutely beautiful. But since we typically don't do the star parties that much past midnight, there was really no point in doing it. So last weekend I was working a weekend, and I did not have time at all to do it. And the moon wasn't really in the greatest position. My problem is my house is on the on the west of where I am right now. So the moon was just over my roof line and going down fast last Saturday, so it just wasn't feasible. Today we're going to be a little bit past. I think we're at 11 days. I think the moon is at 11 days right now. So it's halfway between a first quarter and a full moon. It's a gibbous phase, so we will be seeing some detail on the Terminator. We will lose some detail on craters and features in the fully lit area, but we're going to do whatever we can do, and whatever we can do. Tonight we have the moon, Jupiter, Saturn, moons of Jupiter definitely, and we'll see Neptune. I have looked. Uranus comes up too late. Mars won't be up till after midnight, and it'll be very low in the sky. And from where you're seeing right now, actually you can't really see it right now. It'll just be over my over the roof line. So the camera's staring right up, and it's just a couple of degrees above the horizon. When I was looking at it, I think was it about a month ago or so, when it was that low, it was swimming. It was very difficult to see. I barely made out the one of the polar caps, and that was it. So all right, so at 360 frames right now, I think that's going to be pretty decent. Man, this laptop is just burning up. I don't think this will function very much longer. It's just too hot for this equipment. I should probably put these giant aluminum cooling fins on here just to keep it cool. And yeah, this laptop's almost too hot to touch. So I'm gonna go ahead and stop the capture. Let that go. And again, I'm Chris Modnitsky with the Fort Worth Astronomical Society. I'm hot, sweaty, tired, and I'm gonna go jump in the pool. I will see you in a couple of more hours. Thank you, and goodbye for now.